Okay guys, today we're going to talk about average rate of change. You'll see tables, you'll see functions, different things that you can find the rate of change. A linear function, okay, if you remember, a linear function is one that makes a straight line, y equals mx plus b, has a constant rate of change. It is the same no matter what interval you're observing. The constant rate of change is its slope. So we call the linear function's rate of change slope. So the average rate of change can be found by change in y over change in x. So we're going to do y2 minus y1, x2 minus x1. So y is on the top, x is on the bottom. And you probably remember the little words rise over run. Okay, so if we go down here, we're going to determine the average rate of change between several points for the function. So f of x equals negative 3x plus 2 is our function. Here's a table. If you recall, you're going to take this first number and you're going to put it in place of x into the function. So that's going to give me 6 plus 2, which is 8. And then if you want to pause the video and fill in the other two by doing the same thing, and then come back and check your answers. Okay, so when you put negative 1 in there, negative 1 times negative 3 is 3, plus 2 is 5, 0 plus 2 is 2. So these are your input, this is your output. These are ordered pairs that would make the straight line. Now, you can do this by plugging into the function, or if you're in a table, you can say, how do I get from 8 to 5? I subtract 3. How do I get from 5 to 2? Go down by 3. Negative 2 to 1. Negative 1, add 1. Negative 1 to 0, add 1. So it is the change in y over the change in x. So in this case, my slope, my rate of change, is negative 3. Okay, quick little thought. Does the equation y equals negative 3x plus 5 provide any clues about the rate of change? So if you recall, this is a slope-intercept form. So we have y equals mx plus b. And then the m is the slope. So here we know that before we ever did this, that our slope is going to be negative 3. Okay, and then what is this here? This b, that is our y-intercept. Remember that? That is where the graph crosses the y-axis, and we know x is 0 there. Okay, here, compare the rates of change for this function and this table. These are two different functions. This is function f of x, function g of x. So here, the slope, our rate of change is negative 5, and then it says compare the y-intercept. So our y-intercept there is the point 0, 1. Okay, if we go here, we can't just immediately find the slope, but we can find our y-intercept. We know anytime x is 0, we know our y-intercept. So here, 0, negative 3. Okay, so how do I get from negative 5 to negative 3? Again, and this time I'm going to add 2, add 2, add 2. Negative 1 to 0, add 1, add 1, add 1. So my slope will be 2 over 1, which is just 2. All right, so let's look at comparing. So negative 5 and 2, which one has the greater rate of change? Well, if you look at first, you're going to think negative 5 because it's smaller than 2 because it's a negative. But the negative tells me the direction of the line and not the value of the slope. But 5, excuse me, 5 is greater than 2, so this one here has the greatest rate of change. Then if we look at the y-intercept, is 1 greater than negative 3? Yes, so this one also has the greatest y-intercept. So now we're going to compare the rate of change here. 5 to 2 would be subtract 3, 2 to negative 1 would be subtract 3. Negative 2 to there is 1, and 1. So here we have -3 over 1, which is just -3. Now I'm looking at this line here. If you remember, you can find 2 points on that line, and you can draw a triangle either going up or going down. So this will be rising 1, 2, 3, and running 2. So the slope of this is 3 over 2, which is 1.5. So which one has the greater rate of change? The -3. So that's how you can find the slope from a graph, our function, or some tables. Okay, so let's continue and look here on the next page. So if we look at this graph here, is the slope positive, negative, 0, or undefined? So if you recall, when it slants to the left, the slope is negative. Okay, so here is the slope. So a lot of students get this mixed up. So think about it this way. I can rise any number. So let's just say 2. But I'm not rounding it at all. Can I divide by 0? No. So that would be undefined because of division by 0. Okay, here it's going to the right. So that is a positive slope. And this is a horizontal line. I'm not rising at all, so that'll be 0, but I can run 2, I can run 4, so I can pick a number there. So in this case, the slope is 0. Some of you may have remembered Slope Dude, where he was going like puff, 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 positive, and then negative. And then when he was going straight, when he was skiing, was taking 0 effort, and then bam, he did undefined and went down. So that's another way that you can remember the slopes here. If you haven't ever seen Slope Man, Google him. He's really cute. Okay, so here we have 2 points. And this is where we're going to use the formula that we've seen on the previous page, where we did the y2 minus y1 over x2 minus x1. So the difference in the y's over the differences in the x. Now this y2 is just a subscript. That does not mean you have to start with the second one. But if you start with the second y, you have to start with the second x. Okay? So we're going to find the slope, and we're going to do 3 minus 1, the change in the y's. Since I started with 3, I have to start with 2, so 2 minus 0. So that's going to give me 2 over 2. And so 2 divided by 2 is 1. Now I want to show you that you don't have to start with the second one. You could have done 1 minus 3. And then since I started with the 1, I have to start with the 0. So 0 minus 2. So that's going to be -2 now over -2, which is still 1. So the slope is the same no matter whether you start with the first one or the second one. Okay, here we're going to do 3 minus a -1. And then 2 minus 3. Remember, minus a negative becomes plus a positive. 3 plus 1 is 4. 3 minus 2 is -2. Or sorry, 2, not 3 minus 2. 2 minus 3 brings that is a -1. So that's going to give me a -4 as my slope there. All right, find the slope of the points contained in the line. So 3 minus 5, 3 minus 5, and then -2 minus -2. So 3 minus 5 is -2. This becomes plus. -2 plus 2 is 0. I can't divide by 0, so my slope is undefined. Okay, this last one, you get -3 minus a -6, and then you have 9 minus 3. So -3 plus 6 is 3. And then 9 minus 3 is 6. 3 over 6 will simplify to 1/2. Okay, so that's using our formula. So let's see what you remember about parallel and perpendicular lines. So find the slope of the line shown here below. So if we have this point here, that this one here is not quite there, so let's look for a point that crosses through, so that'll be right here. And then we're going to draw our triangle, so that's 1, 2, 3 down, and 2. So our slope of this line is -3 over 2. Okay, so everyone notice that's -3 over 2. The other way I can know it's negative is it's slanting to the left. All right, so based on this slope, if I have a parallel line, what will the slope be? So what do we know about parallel lines? They have the same slope. Okay, so if it's -3/2 here, if I have a parallel line, it's also going to be -3/2. Okay, so what will the slope of the perpendicular line be? So perpendicular lines have opposites. So if it's negative, it's going to be positive. Reciprocals. So if you remember, that means you're going to flip it. Okay, so it's going to be positive 2/3. So opposite reciprocal. So we flip the fraction. Okay, last problem for today. We're going to find the slope of this line. So here's a point and here's a point. This slope's going to the right, so it's going to be positive. So 1, 2, 3, 4, 5, 6 down. And then 1, 2, and 2 to the left. That makes them both negative. So, but then we already know it's going to be positive, so it's going to be a 3 is my slope. So if it's parallel, it's going to have the same slope. Perpendicular, so if it's +3, it's going to be negative. And then what can I do here? So I could put 3 over 1. And then when I do that, that would be -1/3. Okay, so this is going to be important on the properties and stuff that we're going to be working on this week, parallel lines and writing lines and slope-intercept form and stuff. So make sure you know parallel lines, same slope, perpendicular, opposite, reciprocal. Check plan book. Have a great day.